had molded the understanding and passion for mathematics among young learners. This is the Equationators, your equation fanatical educators. Greetings, students! Congratulations on completing permutation of distinguishable objects. This time, we will focus on permutation of objects with sum alike. With Equationator CJ, you will be guided to making sense of the world that is made up of numbers and probabilities. Halina't matuto na! Have you ever wondered how many unique arrangements you can make when some objects are repeated? First, let us refresh our memory on what permutations are. We know that in permutations, the order of elements is important. When all objects are unique, calculating permutations is straightforward. However, when some objects are repeated, the calculation becomes a bit more complex. That's right, there are two kinds of permutations: permutation of distinguishable objects and permutation of objects with sum alike. Permutations with repetition mean we can select an item twice or more. You have already seen how we can rearrange words like love that can be formed in 24 different ways without having to repeat any letter at all. But how can we arrange words with letters that repeat? Notice that the letters in the word love are distinct or different, while the letters in the word none are not distinct because there are two letter ends in it. This will affect the number of ways you can arrange the letters of the word, and this type of problem is called permutation of identical objects. Now, have you ever wondered how many ways can the letters in the word none be arranged? Let's explain step by step. Since there are 4 letters, get the permutation of such letters. Note that when you get the permutation, you'll be counting some words twice. Next, the permutation of the 4 letters will be divided by the number of ways to arrange the repeated letter. Lastly, simplify. Therefore, there are 12 ways to arrange the letters of the word none. To verify the answer, let us list down all the possible arrangements of the letters of the word none and remove the repeated words. Now let us try another example. How many distinguishable arrangements can be formed from the letters of the word pagpapakatao? Since there are 12 letters, get the permutation of the 12 letters. The permutation of the 12 letters will be divided by the product of the number of ways to arrange the repeated letters. Note that the number of ways to arrange the 3-letter piece is the number of permutations or of 3 different objects taken 3 at a time. That is 3p3 plus 3 factorial, and the 5-letter ace is the permutation of 5p5 equals 5 factorial. And then lastly, simplify. Therefore, there are 665,280 different ways to rearrange the word. Distinguishable permutations are permutations that can be distinguished from one another. In the case of a number of things, where each is different from the other, such as letters in the word bagyo, there is no difference between the number of permutations and the number of distinguishable permutations. But if the original set of things has repetition, then the number of distinguishable permutations is n factorial over n sub 1 factorial, n sub 2 factorial up to n sub k factorial. Let us take a look at an example. If there are 2 cans of orange juice, 3 cans of lemonade, and 5 cans of iced tea in a cooler, and how many ways can these drinks be consumed by a customer? Since there are 10 drinks, get the permutation of the 10 drinks. The permutation will be divided by the product of the number of ways to consume the repeated drinks. The number of ways to consume the orange juice is 2p2 equals 2 factorial. The lemonade is 3p3 equals 3 factorial, and the iced tea is 5p5 equals 5 factorial. Therefore, there are 2,520 possible ways to consume the drinks. Great! You are slowly getting the hang of this. For the 4th example, how many different 8-digit numbers can be written using the digits 1, 2, 3, 4, 4, 5, 5, and 5? First, let's identify the total number of digits. In this case, you have 8 digits. Then, identify the repeated digits. There are 2 4s and 3 5s. Then, calculate the total number of permutations while applying the formula. By plugging in the values for the problem, n is 8, n sub 1 is 2 because there are 2 4s, and n sub 2 is 3 because there are 3 5s. So, there are 3,360 different 8-digit numbers that can be written using the digits 1, 2, 3, 4, 4, 5, 5, and 5. And that wraps up today's lesson of graphing polynomial functions. I extend my congratulations to you for completing the third quarter. This has been your Equationator CJ, aspiring to inspire a love for numbers and problem solving in the hearts of the next generation. Bye-bye!